Okay, so let's get right into it. When you're interacting with an AI, have you ever stopped and wondered, does it actually get what I'm saying? Or is it just an incredibly sophisticated mimic? Today we're going to unpack that very question, which is one of the most fascinating debates happening in technology right now. What is the true nature of generative AI? Just look at this picture for a second. It's kind of weird, right? It's creative, it's specific, and it totally has this forgotten 90s vibe. But here's the kicker. No human made this. An AI generated this entire image just from that simple text prompt you see. And that is the power of generative AI. It's not just analyzing stuff, it's creating something brand new, right out of thin air. So here's our game plan. First, we'll nail down what generative AI actually is. Then, we'll look at the massive breakthrough that made all this possible. After that, we'll jump straight into the big debate. Is it a stochastic parrot? We'll also check it out from an engineering point of view. And finally, wrap up with why this whole conversation matters so much for all of us.
All right, first things first. Before we can get into whether AI is thinking, we have to get really clear on what we mean by generative AI. Beyond all the buzzwords.
The easiest way to get it is to think of two sides of the same coin. On one side, you've got discriminative AI. Its whole job is to be a sorter. It classifies things. Is this email spam or not? Is this a picture of a cat or a dog? It makes a judgment. But on the other side, we have generative AI. It's not a sorter, it's a creator. It doesn't just identify a cat picture, it learns the idea of a cat and then generates a totally new cat picture that's never existed before.
So, how did we get this incredible creative power all of a sudden? Well, that brings us to what is probably the single biggest moment in modern AI, the invention of the transformer.
Back in 2017, a few researchers at Google dropped a paper with this really simple, almost poetic title. Little did anyone know, this paper was about to introduce a new architecture that would completely change the game for AI.
Okay, so here's the deal. Before this, models had to read a sentence one word at a time, in sequence. That made it super hard to connect a word at the beginning of a paragraph with one at the end. The transformer, though, introduced this mechanism called attention. It lets the model look at the entire sentence all at once and figure out how every word relates to every other word, no matter how far apart they are. That's the secret sauce. It's understanding context by seeing the whole picture.
And the effect was, well, you can see it right here. It was an explosion. A year after the paper, we get GPT-1, then a huge jump to GPT-3 in 2020. And by 2022, ChatGPT put this power in everyone's hands, followed by the even more powerful GPT-4. The pace of progress since that one paper has just been breathtaking.
And this incredible leap in what these models can do leads us right to the biggest question of them all. Are they actually thinking, or are they just incredible mimics? This is the core of what we call the stochastic parrot debate.
So, what on earth is a stochastic parrot? Let's break it down. Stochastic is just a fancy word for based on probability. So the term basically describes a system that's just statistically guessing what word comes next, stitching together sentences based on patterns it's seen before. And just like a parrot that can repeat hello perfectly, it's doing it without any real understanding of what hello actually means. It's just advanced mimicry.
And the case for this view was pretty compelling. At their heart, these models are just predicting the next most likely word. They don't have an internal compass for what's true or false. And that's exactly why they sometimes hallucinate. They just confidently make stuff up. And of course, they can only repeat the patterns, including all the biases, that were in the massive amounts of internet text they were trained on.
Here's a fantastic real-world example. GPT-4 was given this puzzle. In the first sentence, newspaper means the company, the publisher. In the second, it means the physical paper object. But when asked if you could swap them, the model said yes, completely missing the difference in meaning. That's a huge piece of evidence for the parrot side. It's showing a failure of true comprehension.
But is it really that simple? Is that all that's going on? And here's the counterargument put perfectly by Geoffrey Hinton, who's basically one of the godfathers of modern AI. His point is, to get this good at predicting the next word over and over with such incredible coherence, you can't just be a parrot. He argues that some level of genuine understanding has to emerge from that process.
And there's some wild data to back this up. For instance, GPT-4 took the uniform bar exam, the really hard test for becoming a lawyer, and scored in the top 10% of human test takers. You simply can't parrot your way through a complex legal exam. That requires some serious reasoning.
And there's more. We're seeing these models solve high-level math problems they've never seen before. Researchers are starting to peek inside the black box, and they're finding that the models seem to be building their own internal world models, little simplified maps of how things connect in reality. There's even some evidence they can do basic planning, almost like they're thinking about what they know.
Okay, so this whole debate can get pretty philosophical, fast. But there's another way to look at all this, a more practical way, through an engineering lens. This approach says, hey, let's stop arguing about whether it's a mind and start treating it like a very, very advanced machine. From an engineer's perspective, this isn't some kind of magic. It's a clear process. You start with a ton of data, you use that data to train a massive mathematical model, you tune and optimize that model, and what you get at the end is a computed probabilistic output. It's all just incredibly complex math and engineering, not biology or consciousness.
So from this viewpoint, what looks like intelligence to us on the outside isn't actually human-like awareness or thinking. It's the amazing emergent result of a massive computation. We aren't talking to a conscious being. We are interacting with a powerful predictive engine. So who cares, right? Parent mind, predictive engine, why does this distinction actually matter? Well, it matters a lot, because how we see it fundamentally changes how we should use it.
If we view AI as a tool, we can be much more clear-eyed about its strengths and weaknesses. Its strengths are incredible, right? It can supercharge our creativity and productivity. But its weaknesses are a direct result of its design. Because it's a prediction machine, not a fact-checker, it will sometimes hallucinate. Because it learns from us, it will absorb our biases. And that prediction power makes it dangerously good at creating fake content.
And that really brings us to the most important takeaway here. The idea isn't to blindly trust some new artificial mind. The key is to use this tool as a powerful partner, one that can help us do amazing things, while we remain the ones in charge, thinking critically, verifying the output, and always staying aware of its limits. And the power of that partnership is just staggering. A study on GitHub's Copilot, which is an AI assistant for coders, found that developers using it were a whopping 56% faster at their tasks. This isn't about AI replacing people, it's about AI augmenting people, making us better and faster at what we do.
So in the end, maybe the whole stochastic parrot debate is asking the wrong question. It seems pretty clear that AI is an engineered tool, a new kind of machine that runs on probability, not consciousness. And that puts all the responsibility right back onto our shoulders. The real question is